Welcome to the Explainer. Okay, let's jump right into this. Today, we are demystifying a piece of tech that is more than likely running on the exact machine you're using right now. But, it's something most of us literally never think about. Well, until we're locked out, that is. We're talking about Microsoft's built-in data protection technology, BitLocker. We're going to look under the hood, decode how this thing actually works, and figure out exactly what it's protecting. And honestly, just as importantly, what it isn't protecting.
So to kick things off, I want you to picture a very real-world scenario. You're working at a coffee shop, you turn your back for a split second, and boom, someone swipes your laptop. It's powered off, and you've got a super strong Windows login password. So your data, your sensitive tax documents, saved browser passwords, private photos, it's totally safe, right? Well, the surprising answer for a lot of people is not necessarily. See, your Windows password primarily acts like a bouncer at the front door of a club. It controls access to your Windows session. But it does absolutely nothing to protect the raw physical storage on the hard drive itself.
And that distinction is absolutely crucial. Without BitLocker, an attacker doesn't even need to guess your Windows password. They don't have to deal with the bouncer at all. They can literally just take a screwdriver, pull the solid-state drive right out of your laptop, plug it into a different computer, and read all your files directly. But once you enable BitLocker, it establishes this firm cryptographic boundary right at the storage layer. If that drive gets ripped out and attached somewhere else, the data remains totally scrambled and completely unreadable. It strongly resists any kind of offline reading.
All right, Section 1, BitLocker's cryptographic barrier, building a digital safe. We are fundamentally shifting away from simple software passwords to some pretty complex mathematics.
To really grasp what BitLocker is doing, we need a super quick primer on encryption. And honestly, the best analogy here is a high-quality, heavy-duty physical safe. Your plain text represents the original readable data, the actual valuable documents you're trying to protect. The cipher is the algorithm. Think of that as the physical construction of the safe itself. It's the complex math that transforms your data. Then you have the ciphertext, which is the scrambled, encrypted data that comes out the other side of that math. And finally, the key. That's your secret cryptographic value. It's the combination to the safe. Modern disk encryption doesn't rely on just trying to hide your files. It relies on making exhaustive guessing of that key computationally impossible. An attacker would literally need a few billion years to crack it.
Moving right along to Section 2, the key hierarchy explained, peeling the onion. BitLocker doesn't just use one simple key. It uses this really fascinating architectural hierarchy.
Let's walk through this authorization flow step by step because it's really cool. Down at the very bottom, your actual raw data is encrypted by what's called the full volume encryption key, or FVEK. But here's the kicker. You never actually interact with the FVEK directly. Instead, it's protected by the layer above it, the volume master key, or VMK. And then, the VMK is protected by your key protectors. These are things like a hardware chip, a PIN, or a recovery password. Now, you might be wondering, why go through all these layers? Well, imagine you just want to update your PIN. Because of this layered onion design, BitLocker only has to update the top key protector layer. It doesn't have to sit there and spend hours re-encrypting every single byte of data on your massive 1 terabyte hard drive. It's just a brilliantly efficient design.
So what is the actual mathematical safe we're using here? BitLocker relies on AES, the Advanced Encryption Standard. You'll typically see a few specific configurations, with the modern default being XTS-AES 128. And I want to clarify something super important right now. 128-bit refers strictly to the mathematical size of the encryption key. That means there are 2 to the power of 128 possible key combinations. It has absolutely zero to do with the number of gigabytes on your hard drive. The XTS part is also a real game changer because it's a mode specially designed for storage environments, protecting against specific types of manipulation that can happen on the fixed sectors of a disk.
Which brings us nicely to Section 3, TPM, the hardware guardian. Because obviously, these keys aren't just sitting around in a plain text file on your desktop.
Enter the TPM, or Trusted Platform Module. This is a dedicated hardware security component baked right into your motherboard. If you've ever wondered how your laptop just magically unlocks BitLocker without you having to type in a crazy long encryption key every time you boot up, well, you can thank the TPM. In standard TPM-only mode, this little chip acts as a guard. It checks the early boot environment and asks, hey, has the firmware been tampered with? Is this the exact same hardware? If everything looks totally normal and trusted, the TPM quietly releases the key, and Windows boots automatically. But if you want even stronger security, you can turn on TPM plus PIN. In this mode, the TPM still does all its hardware integrity checks, but it also demands a secret PIN from you before it hands over that volume master key. It's that classic, super secure combination of something you have, the hardware, and something you know, your PIN.
But what happens when those hardware checks fail? Let's talk about Section 4, that 48-digit recovery password, your ultimate backup plan.
Oh yeah, if you have ever been locked out of BitLocker, you know this massive, intimidating number, 48 digits. And just to be super clear here, this 48-digit number is not the raw AES data encryption key just written out in decimal format. No, it is a very specific recovery credential designed specifically for the pre-boot environment. Why did Microsoft choose numbers instead of letters? Well, numbers are language independent. They are universally accessible on literally any keyboard layout in the world, right from the very first second your computer turns on.
Now, seeing a scary blue screen demanding this 48-digit code can cause instant panic, but it absolutely doesn't mean you've been hacked. See, BitLocker is designed to lock down the safe if it detects any unexpected changes to that early boot environment we talked about. This can be something completely harmless, like your IT department pushing a routine BIOS update, or if someone just fumbling and entering the wrong PIN a few too many times. BitLocker can't always tell the difference between a malicious attacker tampering with your system and a benign software upgrade, so it plays it safe. It defaults to protecting your data by slamming the safe shut.
And that brings us to the absolute most critical warning of this entire explainer. Listen closely. Microsoft support cannot recreate a lost BitLocker recovery key. If you lose this 48-digit number and your TPM glitches out or your motherboard dies, your data's gone. Period. No way around it. No amount of begging customer service on the phone will save you, because the math is doing its job perfectly. This highlights why it is absolutely crucial to securely back up this credential centrally. Link it to your personal Microsoft account, store it in an enterprise Entra ID system, or literally just print it out and lock it in a physical safe. Because anyone who gets their hands on this 48-digit number effectively has the master key to your entire encrypted volume.
Okay, let's zoom back out for the big picture. Section 5. What BitLocker doesn't protect. The threat model. Because while BitLocker is incredibly powerful, it is definitely not a silver bullet for everything.
When we look at where BitLocker shines compared to its limitations, the picture becomes very clear. If your powered-off laptop gets stolen at a coffee shop, or if you throw away an old hard drive, BitLocker is your best friend. It is strongly relevant. But what if your computer is powered on, you're happily logged into Windows, and you accidentally download some nasty malware or click on a sketchy phishing link? BitLocker is not a primary defense there. Think about it. Once Windows is authenticated and running, the volume is unlocked so your apps can read and write files. If malware is running in that exact same authenticated session, well, it can read all those files too.
I really want you to remember this specific quote directly from the source material. BitLocker protects the data when the computer is not in a trusted, unlocked state. That hits the nail right on the head. It's a vital layer of defense in depth. It protects your data at rest, but it is absolutely not a replacement for running good antivirus software, having safe browsing habits, and maintaining strong account security.
So to wrap up the whole shebang today, let's look at this definitive summary. BitLocker is Windows volume encryption that protects stored data from unauthorized offline access by encrypting the volume and controlling access to its encryption keys through hardware and credential-based protectors. That single sentence beautifully encapsulates the entire architecture we just explored together, from the cryptographic barrier all the way up to the TPM hardware guardian. I'm going to leave you with this final provocative thought. Take a look at the device you are using right this very second. If it was lost today, is your data truly at rest, locked tight behind a cryptographic barrier? Or is it just sitting there on an unencrypted drive, quietly waiting to be read by the very next person who decides to turn it on? Seriously, it's worth taking 2 minutes today to check your settings and make sure you aren't relying entirely on just a basic OS login. Thanks for joining me on this deep dive into the